everyone. So we're continuing with trig substitution problems, and here is a problem that I would like to solve for you. Again, look that there is a square root function. First try to do the u substitution, where u is whatever is in the square root. And if you do that, the derivative will be, like negative 6x dx. That x should be sitting outside, but it's not. There is nothing else outside. So u sub will not work. Therefore, you have to do trig substitution in order to get rid of this square root, to remove the square root in the end. Okay. So let's start. Okay. Which identity should we use? So you have to think about the three different ways of writing the identity. Here we have a constant minus the variable. So 1 minus what? Well, 1 minus sine squared theta, right? Is cosine squared theta. Okay? So that's the one we have to use. Therefore, x should be sine theta. All right, but that's not enough. Because if we plug that in, I'll get just 1 minus 3 sine squared theta. We have to cancel that 3 out. So we get only 1 minus sine squared theta. So 3 is attached to x. So how to cancel it out? We will have to have, when you square the x, you should get a 1/3 sine squared theta. So therefore, x should be 1 over square root of 3 of sine theta. If you did not follow what I just said, when I write it out, you will see how things will cancel out and you will just end up getting 1 minus sine squared theta. And do not forget to write immediately down the d of x, because that's a mistake. If you make, the entire problem is wrong. Okay, so what is the derivative? Constant remains as it is, sine theta becomes cosine theta. Okay, so let's come here, plug everything in. So inside the square root, I will have 1 minus 3, now be careful, x squared. So you're squaring everything. So 1 over square root of 3 square is 3, and then sine square. And then outside, don't just change it to d theta, make sure you have the d of x and you write it down outside. 1 over square root of 3 cosine theta, d theta. Okay? So do you see what happens inside the square root? The 3 cancels, and you will end up getting square root 1 minus sine squared theta. That's exactly what I wanted, right? So I can write it as one term cosine square, which is a complete square, and I won't have square root in the next step. And then we have this remaining. So you can pull out the 1 over square root of 3, and you have another cosine theta. So this is, remember, this is cosine square inside the square root, so that means this is just a cosine and another cosine. So the function that you have to now integrate is cosine squared theta. Now you have to recall the previous section where we did all the trig integrations, how to integrate cosine square. So this is an even power only. That means we have to use the half angle formula, okay, which is cosine square is 1 plus cosine of 2 theta over 2. Right? So let's see, what do we get? Another 1/2 comes out, right? And you have 1 plus cosine of 2 theta. And now we can integrate this. 1 becomes a theta plus cosine of 2 theta, antiderivative is positive sine. So positive sine 2 theta over 2. Don't forget the little chain rule here, the anti-chain rule that we are doing, without doing the u substitution, without writing everything out. Okay, so far so good. Now we have to change everything in terms of x. And remember, I told you that we have to go back here, right? And we need to figure out the little triangle. So one other thing in this particular problem, what's happening is, even though everything will be in terms of theta, our answer has a double angle 2 theta. So we have to reduce that into a single angle. So this is where you will need to use the formula, the double angle formula for sine of 2 theta is 2 sine theta cosine theta divided by 2. so that we don't have to deal with the 2 theta, but we can only deal with single sine theta, cosine theta, which is very important, okay? All right, let me come here and draw the triangle right here. So let's solve for sine theta. Okay, so sine theta is, let me write it from here. What is sine theta? Square root of 3x. Okay, and then there is no denominator, that means the denominator is 1. So when I'm drawing my little triangle, here is my theta, see it's a single angle, theta, not double angle. Sine is opposite, so this is opposite, and this is hypotenuse. So opposite will be square root of 3 times x. Remember, x is not inside the square root. And the hypotenuse, there is no denominator, means there is a 1. Oh, sorry, my bad. Hypotenuse is right here. That's 1. Okay. So 2 sides we found out. So how to find the third side using Pythagorean? It's 1 square minus this square, which is 3x square. Okay? Looks right, looks good. So come back here now, and you need to write your answer. So what do we do with the theta? There's no sine, cosine, or any trig in front of theta. So if that happens, if theta is by itself, only then you use the arc sine, or sine inverse in this case, or arc of a trig function, the inverse trig function. Okay, so let's look at it. Sine theta is square root of 3x, so theta will be arc sine of square root of 3x. Remember, only if theta is by itself, you use the inverse trig. Every other one, you cannot write sine of arc sine, okay? Don't do that. All the other ones, you use a little triangle to solve. Okay, so what is sine theta? We already know sine theta is square root of 3 times x. And now we have to figure out cosine theta, which is adjacent over hypotenuse, which is just a square root of 1 minus 3x squared over 1, which I'm not writing. And then that's it. Now we have our answer.